Welcome to Theory of Computation class. Here I am going to give an explanation for diagonal language. Diagonal language is denoted as LD. So if we consider the definition of diagonal language, LD is a set of string Wi and that Wi is not accepted by the language L of Mi, where M is a Turing machine. So if we consider diagonal language LD, which contains a set of strings and no string is accepted by M. So if you consider general notation, if you write a set of strings for a particular language, those all strings should be accepted by M. That is the general notation. But if you consider diagonal language LD, LD contains set of strings, but those set of strings are not accepted by that Turing machine M. Those type of language is called as diagonal language, and the process of forming those set of strings are called as diagonalization. So how can we find the set of strings for framing LD? So we need to take a complement of diagonal values from the square matrix, and that value that does not occur at any one of its row. So how can we prove it? For example, I am going to take 4 different languages. So L1 is a language which contains 0 power n followed by 1 power n. If you consider L2 contains a set of strings as 1 power n, 0 power n. L3 values are number of zeros followed by any number of ones. L4 means number of ones, if any one is occurred, immediately you should write 0. So we should form a square matrix. So consider I am going to frame a string with 4 length. So there are 4 symbols are available, which are namely W1, W2, W3, W4. So if you consider n is equal to 2, the value is 0 squared 1 squared, which will be written as 0011. I write it its corresponding W1 to W4 value. The same n value is 2 for the second language L2 means 1100. So I write it in the corresponding second row. 0 followed by 1 means 01, 01, 01 like that. Here I am going to frame a 4 length value. So the answer is 0101 like that. And 1 followed by 0 means 1010 like that. So I frame a particular square matrix in which I want to write LD values. LD means set of strings. So how can you frame a diagonal value means you take the diagonal value of this one, it is 0100. So here I am going to take the first string 0100. Then you should check whether this 0100 is accepted in L1, L2, L3 or L4. Just check it value 0100. It is not in L1. The same value not in L2. The same value not in L3 and L4. So if you take the diagonal value, that diagonal value does not accepted by any of these languages. So the first string for diagonal language is 0100. So I am going to shuffle this notations. So instead of first row, I am writing first row with the L4 value. So L4 value is 1010. Then I am writing L1 value, it is 0011. Then L2 value 1100. And then last I write L3 value, it is 0101. So consider the diagonal value. So the diagonal value is 1001. So it is WD. Just check this, the 1001. It is not available in these 4 languages. So LD contains this value. That means you should take the complement of that value. So the complement of value is 0,110. It is not available. So it contains the complement of the diagonal value. So once again I write the definition. So LD is equal to WI. WI is not in MI. So how can we frame WI? We need to take complement of diagonal, and that complemented diagonal value does not occur in any one of its row. So like that we can able to form the diagonal values. Okay, then the third notation. So instead of shuffling this, I am writing L3 value first. So L3 value means 0101. So it's not only writing 4 length, you can able to write 6 length value. So 6 length I am writing here. Then L1 value 00011. Then I am writing L4 value 101010. Then L2 value 111000 like that. Then you take the diagonal value. That means 6 different languages. So here I am writing 4 languages. So you write another 2 notations. So here 001101 or 110010 like that. Then you should take the complement value. It is 0010 0010 and then 1. This is the diagonal value 001000. This is the diagonal value, and you should take the complement of this diagonal value. It is 110111. It is not available in any one of this row, so which is also comes under LD. So previously I am writing the string as 0100, second string is 0110, and 6 length strings are 110111 like that. So you can able to form any length string corresponding to its different languages. So this is diagonalization, the process of complement of the diagonal value for construction of a language, and that strings are not accepted by any of the machine. Then that process is called as diagonalization. So if you consider LD is comes under a not recursively enumerable language. Why we say that means this contains a set of complement of diagonal value, but that is not accepted by any of a machine. So no strings are accepted by a machine means then that language is, that problem is undecidable problem. So that corresponding language is not recursively enumerable language, and the output is not predicted in yes/no format. So it is also not recursive. So the theorem will be proved in later class. Here I am giving only the explanation for framing the diagonal language. Thank you.